We are starting with the couplings in mechanical engineering. Now, the term coupling is a device used to connect two shafts together at their ends for transmitting the power. So if there are two shafts which are very lengthy, and you cannot use lengthy shafts because the shafts might bend, they might break. So what do? We join it with couplings so that they can transmit power. There are a number of coupling devices used to couple the two shafts. So there are rigid couplings, there are flexible couplings. We are going to see all of them in detail. Now, like I said, the application of coupling, if someone asks you where the coupling is used, then the longer shafts, longer than the standard ones, if there are the shafts which are longer than the standard ones, then what will happen? They might bend or break. So what do? We join it with couplings. So to couple the shafts, that is the driving machines and the driven machines such as electric motor, pump, diesel engine, concrete mixer, motors, hoists, the couplings are used. Shafts are mostly available up to 7-meter length due to transport difficulty, right? So if more than 7-meter length shafts are there, then you cannot transport it from one place to another. You can, but it becomes a bit difficult. So to get a greater length, it is necessary to join 2 or more pieces of the shafts using coupling. So more than 7-meter length shafts, instead of that, it is better to couple the two shafts with the help of the coupling. So to connect the shafts of motor, generator, which are manufactured separately, and to provide disconnection for repairs. So ultimately, if you want to do some repairing, then the disconnection of the couplings can also be done, and you can do the repairing and again connect the shafts. To reduce the transmission shock loads from one shaft to another, the couplings are used. Even if there is misalignment of shaft, a little bit misalignment of shafts, then also the flexible couplings can be used, like Oldan coupling, universal coupling, push pin type flexible couplings. We are going to study all of them in detail further. So to introduce the protection cover, these things are used. To introduce the protection against overloads, the couplings are used. Now, if we only look at our main mechanical coupling, right? There are fluid couplings, there are magnetic couplings, but we will more focus on rigid couplings and flexible couplings, which are mechanical couplings, right? So mechanical couplings is divided into two parts, rigid coupling, flexible coupling. We are going to see the difference between both of them in detail. So rigid couplings, there are sleeve couplings or muff coupling, split muff coupling. It is also called as clamp coupling. It is also called as compression coupling or flange coupling. Three main types are sleeve coupling, split muff coupling, and flange coupling. Flange coupling, again, it is further divided as solid or forged coupling, unprotected coupling, protected coupling. Don't worry, we are going to see the meaning of all of them in detail further. The flexible coupling are divided as bushpin type coupling, Oldham coupling, universal coupling. So basically, two main types of couplings are there. Two main types of mechanical couplings are there, rigid coupling and flexible coupling. And further, they are subdivided like I told you right now. So what is a rigid coupling? If you see here, I've shown you mechanical coupling. The first type is rigid coupling. Then what is the meaning of that? Rigid coupling is used to connect the two shafts which are perfectly in axial alignment. See guys, even if some amount of misalignment in shafts is there, then rigid couplings cannot be used. They are very rigid. What is the rigidness? What is the condition? The condition is that the two shafts should be perfectly axial. They should be in perfectly axial alignment. These couplings do not allow any relative rotation between the two shafts. So basic three types of rigid couplings are sleeve or muff coupling, clamp or split muff or compression coupling, and flange coupling. We are going to see them in detail further. Don't worry. Further, if you see, you can see the different parts of the rigid coupling, right? So you can see here, basically, these are the two shafts which we want to connect, right? So it consists of flanges. This is a flange coupling. So you can see this is the first part of the flange and this is the another flange. So when you bolt these flange, you can connect these two shafts. Don't worry, further an animation is also coming if you have not understood. But the flange, the muff, this part is made of basically what? Cast iron. Why cast iron flanges or cast iron sleeves or cast iron muffs are used? Now, guys, cast iron is a very hard, very brittle material, and its function is to support. Cast iron provides a very nice support. Here, the coupling is going to support the shaft. That's why they are made of cast iron. And you can see here the keys are there. So the shafts will be connected with keys to the coupling. The flanges are brought together and then they are bolted. You can see the bolts, right? The protective flange is provided to guard. Now you can see here, guys, the bolt are open. But what if I will provide here a cover, right? Then this flange couplings becomes protected flange coupling. Here, since the cover is not there, we will call it as unprotected flange coupling. But here, since the cover is there, we are going to call it as protected flange coupling, right? So it is basically going to guard against the headed portion of the projecting bolt. Now, see guys, the bolts which you are going to see here, they are going to be equally spaced on the bolt circle diameter. We'll come through all these terms. We are going to calculate the detailed numericals of the flange coupling. But basically, I'm trying to say is that this flange which you are going to see here, if you see it from the side view, you will find it as a circle. And the bolts, you will find these bolts that they are equally spaced. You can see I have drawn 4 bolts. So these 4 bolts will be equally spaced on this pitch circle diameter, right? So this is how the bolting of the flanges is done so that they can support the shaft. Now, rigid couplings, what is the advantage of these rigid couplings? They have high torque transmitting capacity, because what is the ultimate goal of shafts? They want to transmit torque. They want to transmit power, right? How do we define, or what is the formula for power? 2 pi nt by 60,000, right? So what is this T? This T is nothing but torque. So it has high torque transmission capacity. You can see here, if I remove the bolts, I can remove the flange, I can then disassemble the shaft. So the assembling and disassembling is very easy with the rigid couplings. You can see the design is very simple and they're easy to manufacture. The manufacturing of the parts of the rigid coupling is easy. Let's go to the disadvantage. See, the biggest disadvantage I told you is that these two shafts, you can see they should be perfectly aligned. Even if the misalignment, little misalignment between the shafts will be there, the rigid couplings cannot be used. They cannot tolerate the misalignment of the shafts and they won't function properly. It can be used only where motion is free. It's not notion, it's actually motion, where the motion is free from shocks and vibrations. So if the shafts is going through a lot of shocks and vibrations, then the rigid couplings cannot be used. You will have to use the flexible couplings. You can see the rigid couplings which are there. Specifically this flange coupling, it requires more space as compared to smaller couplings like muff coupling, split muff coupling that we are going to study further. So guys, these were some advantages and disadvantages of the rigid couplings. Now let's go to the flexible coupling. On the contrary to the rigid flux couplings, the flexible couplings do not use the bolts. They use the rubber bushings over the pins or the bolts. So what will happen because of this rubber bushings over the pin? They can provide some amount of misalignment. They will provide the flexibility that some amount of misalignment between the shafts will be tolerable, and there you can use the flexible coupling. So the coupling is used to protect the driving and the driven machine members against the harmful effects of misalignment, the harmful effects of vibration, the harmful effects of shock, sudden shock loads which are going to come on the shafts. What are the types of flexible couplings? There is bush pin type flexible coupling, there is Oldham coupling, there is universal coupling, right? So these were the types of flexible coupling. The way we saw the working or the parts of the rigid coupling, let us see the parts of the flexible coupling as well. Now see guys, just like rigid coupling, the flexible couplings also transmit power, they transmit torque. But in rigid coupling, the torque is transmitted from one half of the coupling to another. That is through bolts. And in this arrangement, the shaft needs to be aligned very well. But in flexible coupling, you can see here, the rubber bushings over the pins or the bolts is there. You can see here, the rubber bush, or you can see there is a brass bush, right? So these rubber bushings or brass bushings over the bolts will provide the flexibility, and it can accommodate a small amount of misalignment. Because of rubber bushings, the design of pins has to be done properly. The pins which we are going to use, or bolts we call it, its design should be done properly. Don't worry, we are going to see it in detail properly. Now, what are the advantages? See, the biggest advantage is that it can bear axial misalignment. How much? 0.5 mm. Up to 0.5 mm of lateral or axial misalignment can be taken by flexible couplings. It can be bared. And around 1.5 degree of angular misalignment can be bared by these couplings, flexible couplings. It prevents from transmission of shocks from one shaft to another, and it absorbs the vibrations as well, which the rigid couplings couldn't do it. Like I said, that torque transmission is the biggest function of the coupling, right? So it is used for transmission of high amount of torque. Again, the assembling and disassembling of these couplings can also be done easily. Now let's go to disadvantages. Now see guys, since we are using these bushes, right? So the cost is going to be higher as compared to rigid couplings. And you can see the space, the radial space which these flexible couplings are going to require, that is also going to be higher as compared to the rigid couplings, right? So guys, we have already seen the difference. Now let's very nicely see the difference between the rigid coupling and the flexible coupling. See guys, as you know, rigid couplings can only be used when the shafts are perfectly aligned. But even if the shafts are not perfectly aligned, there is even if small amount of misalignment between the shafts, then the flexible couplings can be used. There is no relative motion between driver shaft and driven shaft, right? But here you can see small amount of misalignment is allowed, and small amount of angular misalignment is also allowed in flexible coupling. If the axis of the driver and driven shaft are not properly aligned, then the bending stresses will be introduced in the coupling, and this will lead to fatigue failure. You cannot see such over here because flexible coupling are meant to absorb vibrations, shock loads, impact loads, and overloads. Types you have already seen. I'll again mention here. Muff coupling, it is also called as sleeve coupling, split muff coupling, clamp coupling or compression coupling, and flange coupling. 3 types of rigid couplings are there. While this is bush pin type flexible coupling, it is also called as pin bush type flexible coupling, Oldham's coupling, universal coupling. These are the types of the flexible coupling. Last and the very important part is that rigid couplings don't use the brass bushes or rubber bushes, and its construction is also very easy. Simple parts are used. That's why rigid couplings are less expensive. But if you figure out the different parts of flexible couplings, that makes them very expensive as compared to rigid couplings. So I hope, guys, you've understood the difference between them. One more difference, it might be asked to you in interviews, it might be asked to you in vivas, that you know the difference between the rigid and flexible coupling. But can you tell the difference between the clutch and the coupling? You should know it. See, guys, a coupling is used to connect the driver and driven shaft permanently or temporarily as and when you require. But the clutch will connect or disconnect the driver shaft from the driven shaft very temporarily and at the will of the operator. Means as soon as you press the clutch, what will happen? The driver and driven shaft will disconnect. But as soon as you release the clutch, the driver and the driven shaft will connect and the vehicle will start driving. So here everything is temporary. But in coupling, the driver and driven shaft are connected permanently. Right? So that is the difference between the clutch and the coupling. So guys, some objective types are asked in exam, in different university exams. Then a coupling is a mechanical device that temporarily joins 2 shafts to each other, just like clutch. No, it is false. Not just like clutch. A coupling is used to connect the 2 shafts permanently, not temporary. This is what you should understand. This is the difference between coupling and the clutch. The dash coupling requires accurate alignment. See, guys, rigid couplings, right? They require accurate alignment of input and the output shafts. So here the answer should be B, not. Let's move further. Which is the another name for clamp coupling? See, guys, compression coupling, right, is the another name for clamp coupling. Split, only split type is not the correct answer. If here it would have been written split muff, then that is also another name for clamp coupling. So either you use the word clamp coupling, split muff coupling, or compression coupling. The rest are all wrong. Let's move to further MCQs if there are there. No. Now let's start with the muff coupling construction. See, guys, you already know that muff coupling, sleeve coupling is a rigid couplings. Means small amount of misalignment between the shafts will not be tolerated. Now you can see here, it is made of cast iron. So basically, if you see this view, it's nothing but a cylinder. And you can see there is shaft 1, shaft 2, and this is the key. So basically, you'll bring 2 shafts to each other. You'll insert the key into the keyhole and coupling, right? And this is how the coupling is assembled. I'll show you with animation also, don't worry, right? So why cast iron? I've already told you that cast iron is a very hard material. It will support the shafts, right? So this coupling is very simple and easy to design. You just have to do what? bring the two shafts to each other. In the shafts, you have to insert the coupling, and in the key, you have to insert the key into the shaft and the coupling. So basically, the design is very simple and very easy. It consists of a hollow muff. You can see here, this portion is hollow. That's why you can insert the shaft into this, right? Now, let's move ahead, guys. One more thing, the inner diameter here, this inner diameter of the coupling will be equal to the outer diameter of the shaft. Obviously, that's why it is going to be inserted into this coupling. Let's move ahead. Yes. So you can see, guys, the shaft is there. The two shafts are there. One is green, one is red. I've inserted the key into that coupling and the shafts. So as soon as the shafts will rotate, they are going to transmit the power. So hollow cylinder muff, it is called as muff or sleeve. It is fitted over the ends of the two shafts, and then a tapper key is inserted into it. A key and a muff is used to transmit power from one shaft to another. It is used to transmit power from one shaft to another. You can see there are no projecting parts over here. So this coupling is very easy and simple to. Let's go to another coupling. Now see, guys, the muff which was like a cylinder, now it is split into two parts. It is divided into two parts. It is broken into two parts. That's why it is called as split muff. Instead of full cylinder, we have divided into two parts. We have divided into two halves. The muff is made into two halves of the cast iron material. You can see the black color. And then they are joined by these bolts, right? So what are we going to do, or how it is going to function? First, we are going to bring the two shafts near to each other, right? Then we are going to insert the key, and inside, then from top, we are going to cover it with the bolts like here. So the two halves of this nut, two halves of this muff, they will be joined. So I'll again explain you here. You can see the two shafts, right? Then we'll do what? We'll bring the two split half, then we'll insert the key, and then we'll insert the bolt, right? These bolts are made of mild steel. You do not need cast iron for them, right? They are made of mild steel bolts, so easy removal, right? And power transmission will be there. Now you can see here. See, guys, the two shafts are brought near each other, right? Then the key is inserted, and then the bolts will be joined. Flange coupling is the third rigid type of coupling. You can see here, this is one side of the flange, and same way there will be another side of flange. So this is the one side of the flange, and this is the another side of the flange. And you can see the number of bolts here, the number of bolts here, the number of bolts are tightened. So what do we do here in flange coupling? Instead of muff or sleeve, we have replaced it with the flange, right? So what are we going to do? We are going to bring these two shafts near to each other. We are going to bring the two flanges near to each other. Then we are going to insert the key into the shaft and the coupling, so they will be fixed. Then these two flanges will be tightened with the bolt, right? You can see the projected portion here. No cover is provided at the bolt. Here, no cover is provided at the bolt, right? So that's why these are called as unprotected type of flange coupling, right? Again, since this is a rigid coupling, remember there should be perfect alignment between the shafts. Bolting will help us to do that. protected type of flange coupling. This flange coupling is just similar to previous one, but you can see here a cover is provided, right? So since a cover is provided, protection against the clothes. See what happened? The workers' clothes, right? They used to get trapped over here if the cover was not there. But since the cover is there, now there is a shelter, right? So the workers' cloth will not get trapped, right? A shelter will be provided to the bolt head and the nuts. That's why these are called as protected type of flange couplings. Let's move further, guys. Bush pin type flexible coupling. Now see guys, this is a flexible coupling. Previous couplings that we saw, they were rigid couplings. But here instead of bolt, we are replacing just like flange coupling. See, first thing I need to tell you that this bush pin type flexible coupling is just like flange coupling. Its construction is just the similar. We are going to bring two shafts near to each other. We are going to bring the two flanges near to each other. We are going to insert the key, right? But instead of tightening it with the bolts, we are going to tighten it with the help of the rubber bushes, leather bushes, or brass bushes over the pins. So what will it do? It will provide us a little amount of misalignment, 0.5 mm of the misalignment, linear misalignment will be provided because of these bush pins. Hence, these are called as bush pin type flexible coupling. Thank you, guys.